Hello everyone, and today it's something new that I'm doing. I haven't done this kind of coding before. We will be doing ML coding. So this problem was created by Claude from start to finish. It's beam search decoding. Obviously, this is relevant for large language models. It's how we are um, deciding what would be the next token after each of the tokens. So yeah, I haven't even read this problem. I just copy pasted it here, and I'm using Colab because I think that's closer to the format in which those problems are usually asked. So I'm not optimizing for whiteboard. Let's see how it goes. Okay, so core decoding algorithm for LLM answer engine. We have an input sequence and the next token prediction function and search parameters. We need to implement beam search to find the most likely output sequences. So here we are collecting different sequences. Usually in LLMs it would be just like one specific sequence. Fine. Maintain beam size candidate sequences of at each step. Oh, I see. At each step, expand each candidate with all possible next tokens. Keep only the top beam size candidates by cumulative log probability. Mm-hmm. Mm-hmm. So log probability, if it's a cumulative one, let's figure it out, right? So we have P1, P2, P3 for each of the tokens. So log probability will be, the result will be P1 times P2 times P3. So if we have log probabilities, then this result becomes, okay, oops, under log. So if we want to what does it change? Why do we have log probabilities here? If we take, so it will still be like this will be log P1 times log P2 times log P3. So it will be a more stable calculation, I think, because otherwise we will be, yeah, all of those probabilities, they will become so small that our evaluations will become imprecise. But logarithms of probabilities, they basically span from minus infinity to 0. And if we multiply those logs, I'm assuming we also can only have, we change it so that it's only positive logs, so that we don't have issues with signs. I will need to see it later on. Okay, so stop expanding a beam when it generates stop token ID. Okay, stop all beams when max token new tokens have been generated. Okay, return all completed beams, those that hit stop token ID sorted by score highest first. If no beams completed, return the top beams at termination. Okay, I actually get it. So next token function, so we have a sequence and then it produces us the next token. It produces a list of floats. So log probabilities for each token in the vocabulary. The length of the returned list is the vocabulary size. Okay, okay. Um, hmm. Interesting. How to make this efficient? Okay, that's interesting. Nox token function, we have max tokens, we have beam size, we have stop token ID. And we need to just store the input sequence. Well, that would be an interesting problem. At least if we want to make it efficient. So let's first figure out some things. Let me maybe create some considerations and examples here. So let's say we have a tokens, we will just use IDs, token 1, 2, 3, right? Then we are creating tokens, and the next tokens can be 4, 5, whatever. I see some messages. Let me see what's in the chat, and then I'll get back here. So chat. Okay, there is a person asking me if they want to create an LLM from scratch, from where do I need to start? Well, I would just ask Claude or ChatGPT to help you with this, and they will point you to the right sources, because even your answer is underdefined. You probably need to start with collecting the data set. Also, I can refer you to Karpathy's video. There you have like the simplified solution for this problem end to end. You can look there. Okay, so now let's say we have tokens and we are returning like 4 with probability 0.5, and then 5 with probability 1.3, and then 6 with probability 1.2. And let's say we only need to keep tokens with the highest probability. So it returns, what's this next token? Sequence of token IDs and return and list of log probabilities for each token in the vocabulary. Okay. Okay, so current sequences, running sequences will be the input sequence. Current finished sequences will be empty. So here we will be putting everything that has generated a stop token ID. And I think all of those will be actually, so this will be a heap. So it's not this, it's input sequence, and then 1.0. Okay, what's the log? Logarithm of probability of 1 is 0. So we are assuming that we always have non-zero probabilities. Okay, let's just assume that this is 1 in the beginning. Then we will be multiplying by our logarithms to get the cumulative probability. Okay, and actually I will need to do this so that I will be using heaps to optimize here. Okay, so current sequences, we have a heap, and we need to have a max heap. I'm streaming. Okay, so we need to have a max heap. So we will need to store it as a negative number. And then we will need to multiply absolutes and store again as the absolute, as the negative number. Cool, I guess. Let's do current finish sequences. Okay, then for in range max tokens, so we can generate at most max tokens. Then for current prob, let's call it log prob, and sequence in current running sequences. We will be generating a sequence of tokens IDs, a list of log probabilities for each token in the vocabulary. Okay. I'm thinking, how should I surface the top instances there? Because we cannot have anything better than and then we also need, we need to store those two heaps together, because we won't be able, we need to compare those sequences together. Okay, and current sequences. If sequence minus one equals to stop token ID, then continue, else we will have next token probs will be next token function of sequence, and then probs heap will be equal prob token ID for token ID prob in enumerate next token probs. So then we do heapq heapify. Okay, from heapq import heapq, from heapq import heapq. Heapify. Actually, let's just do import heapq heapify probs heap, and yeah, here we also need to first choose this one, and then we will just need to do the first n of those. So actually, am I incorrect? Do we need to store min heap here? Yes, we will be only storing there the biggest possible values. Okay, and here, what do we need here? Here we actually need to store the smallest possible values. So we need to get the 3 biggest probabilities. So yes, here we need to do that to get the 3 biggest probabilities. So we need to do negative prob here. Heapq, heapify, probs heap, and then okay, let's say if 4 has running sequences will be equal to true, then will be equal to false by default. But then we iterate over all running sequences for probability log p sequence in current sequences if sequence -1 is not equal to stop token ID, then has running sequences equals true. If not has running sequences, break. We basically want to break as early as possible here. And here, let me not overcomplicate this. For for in the date in range beam size. So what do? We do props heap, so log p, let's call it prop. For consistency, token ID equals props heap pop. So then new prob will be equal log p will be equal current log p times, oh no, not times, oh yeah, times prob, and then if not no sequences, then we just do next sequences and with new log p and with sequence plus token ID. Else we already have something. If prob equals absolute prob, so that we don't have issues with all that. So the closer it is to 0, the smaller it is. So consequences, let's just say that we are storing something like minus 2 okay, we'll be storing minus new log. Oh, actually this multiplication will give us negative minus so both of those values are minus, right? So I have sequence 1, 2, 3, then I have here sequence like minus 0.14 for sequence 1, 2, 4. So I will try both of those, and then I will just multiply these with the new probabilities for the next token, and I will be iterating over all of those. But then on the new sequence, let's say I'm getting the probabilities, log probabilities, so they will be like negative numbers. So I'm multiplying, they become smaller. What do I want to do? Which probabilities do I want to choose first? Not the smallest one, I want to choose the biggest ones. So I want to do that differently. So now this will be a positive thing. Yeah, now I need it to be positive so that I start with the smallest probabilities that are the closest to 1. The smallest log probabilities that are... Okay, so for the next token, what we will have is... Let's do here next token probabilities. It will be something like minus 0.1, minus 0.2, minus 0.05, right? So we need to start with this probability. So that means that it needs to be like, if our heap is min heap, this currently is maximum, so we need to take minus probability. Okay, so now they're all positives and they are stored as 0.05, 0.1, 0.2. And then we need to, like, let's say this beam size is this, so we just need to take these two. And then for this we will be multiplying. So current log p, okay, we don't need minus here because one of those will be negative and one of those will be positive. So next steps append. Okay, now we are always storing those as negatives. If our current new log p, which will be negative, is bigger than next sequences, 0 and then 0. So if it's bigger, then we need to do heap q, heap pop, next sequences. And if this, and then we need to put it back, so heap q, heap push, props heap. Okay, so now we again have negatives. And length next sequences is equal to beam size. So if in those two cases, when it's bigger than the current sequence and its length is already beam size, so we need to or length next next sequences is smaller than beam size, then we do heap push, and our next sequences we are pushing this value. Okay, now finally, after we have done all this, we just need to do current sequences equals next sequences, and next sequences equals an empty list. Okay. List of completed sequences, including the original input sequence prefix, sorted by cumulative log probability, highest best first. If no beams completed, return the top active beams. So I need now to create my answer equals this. So while current sequences, we are just returning what? List of integers. So yeah, we are just returning sequences. So we need to remove our log probabilities also. So first in our sequences list will be the sequence that is the worst one, right? So we will be popping those one by one. So we kind of are doing heaps sorting and populating these to the answer. So while current sequences, we do what? We do log p sequence equals heap q heap pop current sequences, and then answer append sequence, and then return reversed answer. Okay, wow. That was complex, more complex than I expected. And I also didn't explain things, so I need to explain things and how I will be running things and why I'm using heaps. So let's just figure out the time complexity here. So here I have max tokens. So let's say that it is of m, and this is of beam size. Let's call it b. So always in our sequence we have at most beam size sequences. Then for candidate in range beam size. So here, here this is the biggest operation. We need to do all vocabulary things. So yeah, essentially here there is no way around this. It will be all big O of vocabulary. But then for this vocabulary, it will be like finding the smallest one will be of log b, because we are just doing it like this heapifying is also of vocabulary, to be clear. But then for candidate and range beam size, so we just need of beam size, and then for all of those candidates we will be doing log b operations. Oh, log v operations of log v. So it will be b log v operations in total here. And then that's it. All of those will be smaller. So in the end, our total runtime complexity will be big O of max tokens times beam size. Yeah, we also need on each of those steps, we're adding the sequence. So it's also like, let's say O of n is length of the sequence. We are doing also O of n operation here. So O of m times b times, and then for each of those, we will have v plus v times v plus b log v and times b times log v. No, b times log v plus n. And n is the current length of sequence. Yeah, so it will be something crazy like this. That's what I'm gathering from this. Oh, actually, I also made a mistake here. Let me just correct this. Okay, so this is very complicated. What are the tasks lists? Reverse iterator has no length. Okay, yeah, I understand. I hope that it returns the list, but it doesn't return the list. We need to do that. Now what? Okay. Let's see. Oh, so max tokens. So what are we passing as max tokens here? Oh, max tokens is the total number of tokens. It's not number of tokens that we are generating more. So let me just change that. Max tokens will be equal max tokens minus length of input sequence, and if generator tokens equals 0, return input sequence. Yeah. Then here we will need to use our generator tokens, and that's better, but this will still not be passing our tests. Okay, that's interesting. So it seems to me that this should be correct, because log probability here, log probability of 3 will be 0 something. Okay, so let's see. Input sequence, okay, 0. So after 0, make deterministic model. Okay, so it's just based on the last token. Okay, so 0, 1, and 2 have these probabilities. So after 0, we get 1. Yeah. For whatever reason, we are not even getting 1, right? Okay, I'm at about 43 minutes. Good that I'm training this in this right now. Yeah, I should have started with something simpler than all of those heaps and everything. I should have also created a different formatting for this function, so that it would be much easier to debug. All of this is a mess. Yeah, I will probably stop now and figure it out offline. Thank you, everyone.